Hey, happy Monday, guys. It's what's today? Is it O day? I can't quite remember. I think it's M was movie day was Thursday and it's O day. I don't even know what that is. I can't even remember what. Oh, it's old school day. Now I got it. See, I'm making this Sunday, so I can't remember. I got to figure out what my old school uh what my old school kind of costume's gonna be. But old school. All right, awesome. So happy O Day. We are near the end of the school year. We got 2 more weeks of like 2 more full weeks of the school year left. It's amazingly beautiful outside. We got sunny 90 plus degree weather. I hope you guys are getting outside. I'm gonna show you some pictures of something I did this weekend or today actually, and I'm trying to. I'll show you some pictures in a bit. But first, I want to get into what we're doing today. This is a image of what some of our students did last week. So I started putting together our Sierpinski's triangles, which were due on what? They were due on Friday. So if you still haven't finished it, please do. I'll still accept it late, but I just want to show you how cool some of the work is that some of our students are doing. This one, I just grabbed a few of the people that were in person on Friday. We started putting them together. So this is Elliot, this was Jordan's, and this was Malik's Sierpinski's triangles. Aren't those beautiful together? Aren't they cool? So we put them together, and we wanted to show you that when you take three smaller Sierpinski's triangles, you can keep building this pattern. So we increased the pattern up, and check this out. Look what happened then. We went the next step, and we took it up to this. Check it out. Those three I just showed you, they're on the top, right? That's Elliot's, Malik's, Jordan's, and then we added a whole bunch more. So we added, let me see here. I don't think I'm going to get this right on who's, everybody's who is in here, but I'm going to get close. Oh my gosh, I don't think I'm going to make it. Let's see. We had oh, I should have thought this out. But look at this giant Sierpinski's triangle. Isn't it beautiful? This giant Sierpinski's triangle. It's pretty great. So I think the other people are participating in our Sierpinski's triangle were Cassidy. I think Cassidy's might have been this one. We had Caroline. We had, let's see, Haley was in here. Maybe this one was Haley's. I can't remember. One of these is Haley's. And one of these was it who else contributed? Was it William? I think one of these was Williams. And then we went over and got a couple fifth graders. This one was Betty's from fifth grade, and she did like some crazy little triangles, if you can see in there. And I think this one was Nathan. So we put them all together and made a giant Sierpinski's triangle. And oh my gosh, I love this stuff. I think it is so cool to make these patterns. So that's what we did in class on Friday. And I sent these out to your teachers, and maybe they sent these and showed you these as well. But I'm just super impressed that you guys, when you built these out of, you started with a blank sheet of paper, built these amazing things, and then we're able to put it together and make an even larger one. And if we had all of our students here, we could make a giant one to fill the whole wall. It would be so amazing. So this is 9 of our students putting their work together to make something really creative and beautiful. So I love that. I love that. I wanted to show you now we're going to do a bit of a note card, and I wanted to show you, before I show you the note card, I'm going to switch to another screen and show you what we're going to talk about today. Check this out. Let's hope this works. All right, is my face going to show up? All right, I think it worked. These are the Platonic solids. So some of you know, I've talked about Plato before. Plato was a Greek philosopher from like around 500 BCE, which is about 2,500, 2,600 years ago. And this idea of pure shapes. And that's what he was kind of looking at, what he was thinking about. So we call these the pure shapes, the Platonic solids. And the reason they're pure is because these are the 5 shapes that you can make that are made out of perfect polygons, meaning like a equilateral shape, like a shape where all the sides are exactly the same, and a shape where all of the polygons that make it up fit together perfectly with nothing else. So it's like one polygon covers the whole thing. And as you can see, some of these we know really well, like the cube. The cube is made of 6 squares, and you can see it right here, a net. We did a lot of those, right? A net of a cube. So a cube, also called a hexahedron, because it has 6 sides. So that's one of our Platonic solids. Another one, even simpler, is the tetrahedron, which is basically 4 equilateral triangles fit together. There's 3 around the top and then 1 at the bottom. So it's also like, you could say it's a triangular pyramid, but it's called a tetrahedron because it has 4 sides. And then you get a little more complex. Check this one out. This is called the octahedron because it has 4 sides at the top and 4 sides at the bottom. And when you make it solid, it becomes just all of the outsides of it are all regular equilateral triangles. Over here, we get to the dodecahedron. That one is 12 sides, all of them pentagons. So now we've got squares, we've got equilateral triangles for these two, and then now we've got pentagons for the dodecahedron. And dodeca means 12. So 10 plus 2, 12. This has 12 perfectly equal sides, all of them being pentagons. And then the last one, the coolest one, look at this crazy thing. It's called an icosahedron. And look at the net for that. Oh my gosh. Icosahedron has 20 sides. So if I stop it, we could count. Look at how complex these are. I can stop them. Isn't this website great? We can stop them all, right? And you can look at these and say how many sides they have, and it's really hard to tell, right? Like especially the icosahedron, super complicated. But look, it's all the same simple equilateral triangle over and over again, but it allows itself to be almost tessellated in a way, except that it's not flat. It's tessellating into 3 dimensions, and that's what makes the icosahedron. So 3 of the Platonic solids are made from equilateral triangles. And we, this week, are going to be making equilateral triangles into tetrahedrons and then into much more complicated Sierpinski's triangles, like really cool stuff, or Sierpinski's kind of like a 3-dimensional Sierpinski's triangles, which is amazing. So we're going to now go back to whiteboard, and we're going to look at your note card for today. So I do want you to write this down in your notebook. I want you to submit it. It's going to be worth a normal amount of points. Just do it now. Turn it into me. Upload it. And this will be, we're going to do probably 1 note card this week and probably 1 next week. So this is still part of your grade. And our note card is on the Platonic solid. So knowing what we just went through and talked about, we're going to look at these. Oh, I'm sorry, wrong page. We're going back to this. We're going to go to our note card right here. I'm going to move my head just a bit, right? And I'm going to move this over just a bit. All right, so your note card today, and you can pause it when you want to. You can pause it to take these notes, but I'm going to talk you through what it says, and then we're going to identify the shapes below. We're going to identify these. We just did this. We're going to say what they are, how many sides for each one. So a Platonic solid, named after Plato, was that there are 3D shapes where all sides and vertices, that means the plural of vertex, all sides and vertices are the same. So these are the 3 conditions they have to meet. And you have to write this down, by the way. Write these down. All faces are regular polygons. So a regular polygon is like a square, right? Or an equilateral triangle. Those are regular polygons, right? A pentagon, where all the sides are the same, is regular. All faces are congruent. Congruent is the math term for meaning the same. All the faces are the same. So all faces are regular polygons, and all of them are the same. It's not a mix of different ones. It's the same one over and over. And then the last one, all corners or vertices are congruent. And that means the same number of faces meet at each vertex, right? Totally amazing. These are like amazing shapes. And you think, oh, a cube, big deal. It is. It's a big deal. All right. So write that down. If you want to pause it right now when you're watching the video, you can. If your teacher wants to pause it so you can write that down, great. Now we're going to talk about each of these. After the pause, we're going to talk about what these are. So I'm just going to identify it. So if you want, what you can do is try to sketch these out. I think you can sketch a cube. You might want to trace off your screen. And then we're just going to give some of the qualifications for each one. So the first one, we're going to say right here, this one is a tetrahedron. Maybe I'll move this up. Let's move this up. Let's do this. Let's move this up here. Okay, these are the 5. And right below it, we'll write what they are. So I'm going to write down right here what they are. So this one is a tetrahedron, and this has 4 sides, right? And that's where the tetra comes from. And we're going to say equilateral triangles, 4 sides, equilateral triangles, okay? So those are the key things here, okay? Now we're going to look at, I'm going to change the color to like this pinkish color, and let's find a nice pink. It takes me a while. I don't know why it took me that long. Okay, this one, we're going to write down cube, right? And a cube has 6 sides, right? And we're going to say squares, all, that's a terrible all, but a terrible A, all squares. I'd like you to write that down. If you can trace that shape, these two shapes are easy, right? Those two you can draw. Now the next one, we're going to go with a little bit of a green. Let's go with this color green. We're going to say this is called an octahedron. And the octa means 8 sides. So octahedron. And we're going to say underneath it, 8 sides. And we're going to say, once again, equilateral triangles, right? So this is the same triangles that made up the tetrahedron. They also can come together to make an octahedron. Okay, next one. Let's make sure I can get this one right. This one's tricky. This one is the dodecahedron. So deca, do means 2, deca means 10. Dodecahedron, right? These are, I guess, Latin roots, I guess. And we're going to say 12, should I say sides? Yeah, 12 sides. I should say 12 faces, but 12 sides. And we're going to say all pentagons. So all pentagons. And remember, pentagons have 5 sides. All right. And we're going to try to not to run out of room here, but we're getting real close to running out of room. Let's make this one orange. The last one of my favorites and one of the most complicated, and I've actually built this before. It's so cool. I might teach you guys how to do it if you want to try, if you really want to try. This is called the icosahedron. It has 20 sides. Oh my God, 20 faces, 20 faces. And it has once again, all equilateral, right? Equilateral triangles. Bizarre, right? And amazing. All right, so what I want you to do for your note card, it's a long note card. I'll give you extra credit if you can draw all of those in. If you draw them well, I'll give you some extra bonuses. But these are what are made up. So tetrahedron, cube, octahedron, dodecahedron, icosahedron, right? Amazing. Let's see, we're at 12 minutes. Pretty awesome, right? Isn't that great? Okay, so this is what you want. If you want to pause it here, you can take down your note card. Fantastic. We're going to be building tetrahedrons this week, and I'll show you how. And you're going to need a few things, but this is incredible, okay? So I also wanted to show you one other thing. Check this out. I'm going to go off of this note card now. I'm going to show you the screen. I've been trying, much like I showed you guys in class, you know, My Octopus Teacher, the Netflix movie that I've been showing some of my science classes. I love this movie. But in that movie, the guy talks about swimming in cold water and your body gets used to it. So I was like, you know what? I'm going to try that. So every day, even though it's been crazy warm, which is wonderful, every day I've been swimming in the lake for like the last week or since it got a little warmer. And even a couple weeks ago when it was warm, I started swimming too, right? But the water is freezing cold. So like when it's 90, 94 degrees out, 93 degrees out, I jump into the water. The water's like 50 or 52 or 53 degrees. It's so cold. So I've been testing it. And I've been like, can I stay in the water? So this morning, Sunday morning, so that for you guys it'll be yesterday morning. Sunday morning, I went to the lake. The water was about 52 degrees, 53 degrees, very, very cold. The air temperature is very warm, like probably 90. I swam for a half hour. I stayed in for a half hour. I swam back and forth. I stayed in pretty shallow water where if anything went wrong, where I got too cold, I could really easily get to the shore. So I swam back and forth from that little steel pole on the north side of the point all the way to the area where the concrete coffins are. I don't know if you know the point, you know what I'm talking about. And I swam back and forth 3 laps each way. So one way back, one way back, one way back. So I was in for exactly a half hour. My body felt great, but I was really, really cold. So I got done. I dried off. I biked home. I was okay, right? But I didn't feel the heat anymore. I didn't feel sweaty. I didn't feel hot. I was just chilled. I was chilled. I was totally chilled. I went home and I took my temperature. And you guys in person know we keep taking our temperatures and they're always like 97, 98, 99, right around there, right? A half hour after I swam, my body temperature was 92 degrees. A half hour later, 92 degrees. So I must have chilled myself, totally chilled myself. And I don't know if that's good for me or not, but I was fine. I felt fine, but I definitely felt like I was not hot even a little bit. I was so I chilled myself by swimming for that long. But yeah, so I'm going to keep trying it. Like the octopus teacher, my octopus teacher in that movie, he says the temperature of the water was 9 or 10 degrees centigrade, which is, or Celsius, which is actually significantly less than 54 degrees. It's almost in the high 40s. So he's swimming in even colder water than what Lake Michigan is right now, which is impressive. And he stays in for a long time. So anyway, all right, back to the note card. Check this out. Remember, note card, awesome note card. I'll see you guys soon. Bye, everybody.